Okay, so anytime we start tackling a case where we're looking at a word problem, where we have to go pick out the data in it, what we want to figure out is what kind of study design is this? That's the very first thing we want to do. So there's some clues we want to look for. And in this case, it uses the words cases, it uses the word controls. But the big way you know this is a case study is because they started by finding people with the disease, and then they worked backwards to go find people to match them who weren't sick. Anytime we start with the health outcome of interest, we're looking at a case control study in this kind of scenario. So when we look at this, what was it looking for? What were the two variables we're looking at? They were looking at smoking, and they were looking at lung cancer. So when you look at these two things, which one of these is the health outcome of interest, it becomes pretty clear that lung cancer is our outcome of interest. And it becomes pretty clear that the exposure of interest, therefore, is smoking. Now, when we talked about the operationalization of something, it means how do you take the idea of smoking and make it measurable? Is it anyone who's ever smoked in their life? Is it someone who only smokes 1 pack a day? How do they determine what is and is not a smoker? And in this study, when you looked at it, it said a smoker was defined as anyone who had, anyone who had at least 1 cigarette a day for at least a 1-year span, right? So this is how they operationally defined whether or not you were a smoker. Now lung cancer is in here too, right? And so we go look in here and it doesn't have anything. It just says lung cancer. So we're going to say positive for lung cancer as how they operationally define this one. I'm sure in the research paper they went into more detail on exactly how big the cancer had to be considered. However, in this one they did not. Okay, so the next thing we want to do, so we have our exposure, we have our health outcome. Who are our cases? Our cases are anyone with lung cancer, right? In a hospital. They found people in a hospital with lung cancer. Hospitalized people. Alright, so who are our cases and who are our controls? How did they find our controls? So if you go back in here, you see they found 709 lung cancer patients, right? I'm looking right here. 709 lung cancer patients in 20 London hospitals. And where did they go find the matches? So they had to find a comparison group, our control group. 709 non-cancer patients from the hospital and in the general medical and surgical patients. So when we looked at our 3 types of ways of getting our controls, one of the ways that we said was you matched them in hospitals. And so this place used the hospital, and they found people who were general medical and surgical patients, not lung cancer patients, as their control. So they used a hospital-based sampling method, not a population-based where they would go find someone in a similar zip code or area of geography. They also didn't ask them, the patients, for contacts of their relatives. So our way of getting our controls was through hospital-based sampling. The next thing we need to do is conduct our 2x2 table. So in order to construct our 2x2 table, we very first we want to start, we have our 3 lines down, got our 3 lines over, right? Our exposure goes on the left-hand side. Our exposure goes on the left-hand side, and in this case, our exposure is whether or not you're a smoker, right? So, smoker. Yes. No. Our health outcome is lung cancer. Yes, no. Then we have to go in and find our data. So the very first piece of data that we normally get in case control studies is the total number of people who are cases, because that's where we start in the case control studies. So where do we find that? We find all the people with lung cancer. And where do we want to put them after we find all the people with lung cancer? All the people with lung cancer, all our cases go here, right? So where do we go find that number? We find 709 cancer patients in here. So we put 709 cancer patients, and then we went out and found our controls, and we found exactly the same number of controls. That is always not the case. Typically, we have more controls than cases in most studies, but in this case study, we actually had the same amount. So we have 709 cases, we have 709 controls, and then after we go find these people, we go ask about their exposure. We ask about their smoking habits. And actually, this study specifically had a 3-page questionnaire that asked about their smoking habits. And if you'd like to see the full study, I've posted it up here for you. And so we got to go find the people who smoked at least one cigarette a day for at least 1 year of their life. So among lung cancer patients, those people who said yes, they have lung cancer or got diagnosed with lung cancer, among those, it said 688 were smokers. So among those who smoked, how many of them were yeses? That means 688 go here. Then, among our controls, so all those people who do not have lung cancer, among our controls, all our people in this column, how many of them smoked? Well, among those, 650 were smokers. That does not look clean. All right, what do we do next? We just subtract. It's simple subtraction. So in this case, it's 59. And in this case, it is 21. So then you can add across, but really in case control studies, these are the only boxes you absolutely need filled. But let's add them all in just to show what's going on in this study. So altogether, we have 8, 3, 13, 38 who did smoke. Very few non-smokers at this time period in the world. All right, 80 non-smokers. So altogether, we should have 14, 18 as far as smokers. And it should add down this way and add across this way to the same number for the total sample. All right, that's our 2x2 table. What do we have to do next? Next thing we want to do is calculate our odds ratio. And when we're saying calculate the association, that's the strength of the relationship between the exposure and the outcome. And in case control studies, we're talking about an odds ratio. Okay, so odds ratio. How do we calculate our odds ratio? A times D over B times C. Okay, so when we look back up at the top, A times D over B times C. Let's put those numbers in. So 688 times 59 over 650 times 21. You might want to put these in just so you remember the order of operations on this. And I am going to calculate this right now because I haven't done it yet. So 688 times 59 divided by 650 times 21 equals 2.97 3. And in our class, we're always rounding to the 10th, so we come up with 3 as our answer. So the OR equals 3. Now, how do we interpret that? How do we interpret that? Well, the interpretation of that would be individuals who smoked had 3 times the odds of lung cancer compared to non-smokers. That was how we would interpret that. The other way we could interpret that would be, well, what do we have to do in order to transform it from a times the odds scenario to a percentage scenario? We'd have to make sure, because OR is greater than 1, right? We have to subtract 1 from it. So 3 minus 1 equals 2 times 100, because we're looking for a percent, 200%. Individuals who smoked had 200%, were 200% more likely to have lung cancer compared to non-smokers. So what do we say when OR is bigger than 1? We have a risk factor. Right? OR bigger than 1, it is a risk factor. And that's how you would complete this activity.